Hello, this is Ravi Pandurangan, Senior Faculty for Physics in RAMABANAM IIT-JEE and NEET Academy. Today we shall discuss a small concept regarding the pulley systems, how the blocks are going to move up and what are the constraint equations. Generally we solve the problems by constraint equations, but now we are going to adopt a small technique. That is, whenever 2-3 blocks are there, when they are moving up and down, the work done by internal force will be 0. For example, let us take this problem here. Here are one fixed pulley, two movable pulleys, one block A, block B. Now I want the relation between the velocities of A and B. What is the relation between the velocities of A and B? Now instead of solving by constraint equation, taking L1, L2, L3 and all that, we are going to take the tension, which is the internal force. Tension, the work done by the tension on the whole system will be 0. Work done by tension on the whole system will be 0. So that's what we are going to use now. Let us say this A comes down and B goes up. Tension here, let us say T, here also T. Same string, so same tension will be there. Here it will be 2T, here also 2T, so here you will have 2T, here you have 4T and here you have 4T. Again I am explaining, here the tension is T, throughout the string the tension will be T, and in the string in the above this pulley you will have 2T, so throughout the string 2T will be there. And next we have above that 4T, 2T plus 2T, 4T, and that 4T will be throughout the string. Now tensions are the internal forces here. So what we are going to do here is, we are assuming that this is going up. Let us say the velocity here is VB. I will take this as VB and this as VA. We want the relation between VB and VA. Now sigma TV is 0. This is the most important concept. That is, tension into velocity. Tension is nothing but force. Force into velocity is power. Power is also work done only, but it is the work done per second. So what we take is work done. The work done by the internal forces is 0. So that's what the concept we are going to use here. Here 4T plus 2T plus T. 7T is upward. 7T upward. And you have the, we are assuming that this is going upward, so VB into the angle between the 70 and VB is 0, so cos 0 is 1, Fs cos theta we take 1, whereas for this if you take VA is down, T is up, tension is upward, this is coming down, the angle is 180, so minus T into VA equal to 0. So the solution is only one line here. Again I am repeating, 70 into VB. Actually we should write sigma TV cos theta. If it is 0, cos 0 is 1. If it is 180 degrees, cos 180 is minus 1. So we get minus here. So 7 VB equal to VA. So we got the relation in one step. So if you want, the displacements also will be in the same relation. Acceleration also will be in the same relation. If you want acceleration relation, AA will be equal to 7AB. That means the velocity of A is 7 times the velocity of B. So in other words, we can write sigma TV equal to 0. Of course, sigma TV into cos theta. I am not writing cos theta here. Theta will be either 0 or 180 degrees. Okay. So this is how we solve the problem. Work done by the internal forces is 0. So I can write the better form of writing this as sigma TV cos theta is 0. So this is the better way of writing. If the angle is 0, sigma TV equal to 0. If angle is either 180 or 0, then I have to write sigma TV cos theta equal to 0. In the first case, 70 and VB are in the same direction. So cos 0. So cos 0 is 1. Whereas here VA is downward, tension is upward. Angle is 180, so cos 180 will be minus 1. So you got a minus sign here. So this is the relation between the velocity of block A and block B. Instead of using the constraint equations like taking L1, L2, L3 and solving the equations, this is the most trickiest way of doing the problem. We can go on to the next problem also. Just let us take one more problem. Okay. Let us see one more example. We can take what is the velocity of block B at the instant shown. We are taking a pulley system here. So we will take A, B, C blocks, A, B, C. The velocity of A, I will take 1 meter per second, and this is 3 meters per second downward. So in this problem, we want what is the velocity of block B. Block B is here at the instant shown. When you released, these are moving, the blocks are moving. We are not worried about the masses. Whatever the masses may be there, the velocity of this is 1 meter per second upward. The velocity of C is 3 meter per second downward. At that instant, what is the velocity of B? Here again, we are not going to use the constraint relations like L1, L2, L3. Instead of that, work done by sigma TV cos theta equal to 0. Work done by, I am writing here, work done by internal forces on the system equal to 0. This is the most important statement which you have to keep in mind. Work done by internal forces on the system is 0. So let us come back here. T is, here I will take T upward, on the pulley T downward. See the arrow marks? I am putting the arrow marks here. So here I will take T, here also same string, so tension will be same. Here 2T, here it will be 2T. Now work done by the internal force on the system will be 0. 2T is upward, 1 meter per second upward. Angle between them is 0. So TV cos 0. Cos 0 is 1. So I will take T is 2T, V is 1, cos 0 is 1. I need not write there because the angle between velocity and the tension is 0, cos 0 is 1. Next, come back here. Let us say this block will move up. We don't know whether B is going to move up or down. We don't know whether B is going to move up or down. We assume that B is moving up. So T is upward plus T upward, VB. What is the angle between T and VB? 0, cos 0 is 1. So I need not write into 1, I have to write, I need not write that 1. Whereas this is coming down, it is given in the question. This block C is coming down, tension on the block is upward. So angle between the tension and the velocity is 180. So minus T into 3 is 0. See, we get the solution by one equation, that's all. Only one equation. Once again I am repeating here, 2T into 1 plus T into VB minus T into 3. Why minus sign? 180 degrees here, so cos 180 minus 1 there. So T gets cancelled there. 2 plus VB minus 3 equal to 0. So VB is 1 meter per second. So we got 1 meter per second VB value. Now listen very carefully. We got a positive answer. Positive answer indicates that our assumption is correct. We assume that B is going up and I got a positive answer, so our assumption is correct. Had I got a negative answer, if I had got negative answer, we have to change the arrow mark, that's all. So we assume that it's going up and it is correct because we got a positive answer. So velocity of block B is 1 meter per second. So this is the beautiful technique. Instead of using the constraint equations, this is a wonderful technique here. We are using sigma TV cos theta is 0. Sigma TV cos theta is nothing but power or work done per second by the internal forces is 0 on the system. Here the internal forces are nothing but tension. But tension you have to be very careful. Here T, here it is 2T, because T plus T, here 2T. So in that way the problem can be done very easily. One more problem we will see. What is the relation between velocity of wedge and rod? Okay, now I am going to take a wedge here. This is the wedge, theta is angle, and I will take a rod and these are two walls here. Okay. Now this rod is constrained to go vertically down, the wedge is constrained to go horizontally. Again I am repeating here, rod is constrained to go down, wedge is constrained to go horizontally. If I replay, just look at this here, rod is constrained to go downward, vertically down, wedge is constrained to go horizontally. Why the rod has to go vertically down? There are walls which doesn't allow the rod to go either right or left side. So now we are going to use one wonderful concept here. The component of velocity perpendicular to the surface, the component of velocity perpendicular to the surface should match. That means I am taking these points. Let us see here, these 2 points. If I take the velocity of the wedge will be in this direction, velocity of the wedge, velocity of the rod will be in this direction, velocity of the rod, okay, because the rod is constrained to go downward. Now what is the component of velocity perpendicular to the surface for the rod in this direction? This is theta, 90 minus theta, this will be theta. This theta, 90 minus theta is theta. So this is VR cos theta, VR cos theta. Now the velocity of the rod is downward. I am taking the velocity of the rod perpendicular to the surface of contact, perpendicular to the surface of contact. I am taking that. Similarly, I have to take velocity of the wedge perpendicular to the surface of contact, velocity of the wedge perpendicular to the surface of contact. So let us see here, this is 90 minus theta, VW in this direction you have VW cos 90 minus theta is sin theta, VW cos of 90 minus theta is sin theta. That means velocity of the wedge perpendicular to the surface is VW sin theta, velocity of the rod perpendicular to the surface is VR cos theta. Both should match. That is the concept where we have to use whenever two bodies are moving, one body is moving over the other, the velocity at the point of contact perpendicular to the surfaces should match. Again I am repeating, velocity of the points of contact perpendicular to the surface should match. So perpendicular to the surface, what is the velocity of the rod? VR cos theta. Perpendicular to the surface, what is the velocity of the wedge? VW sin theta. They have to match. So I can write VW sin theta should match with VR cos theta. So VR is VW tan theta. So this is the relation between the velocity. VR is VW tan theta. So we got the relation. instead of differentiating, doing so many things or moving the wedge, the best way to do the problem is whenever two surfaces are in contact, the velocities of both the bodies, perpendicular to the surface, the components perpendicular to the surface should be equal or they should match. That is what we say, or the relative velocity should be 0. So, velocity of the rod perpendicular to the surface is Vr cos theta, velocity of the wedge perpendicular to the surface means surface of the wedge, Vw sin theta, that is Vw cos of 90 minus theta, they have to match. So, after matching we get this relation. Okay. We can go back to one more example. So, this is the very best technique to do the problem. One more example we will take, then you can understand. Okay. Find the reading of spring balance in the diagram shown. Here you have the spring balance. Three kg, 1.5 kg. The whole system is inside a lift I will take, which is going up with acceleration g by 10 meter per second square. Okay, let us first see what is the question. Find the reading of the spring balance in the diagram shown. We have 1.5 kg here, 3 kg here. It's a light pulley. If I don't mention, you have to take it as a light pulley, and you have a spring balance here attached, and the lift is going up with acceleration of g by 10. Now, if I do this problem by conventional method, it will take 2-page solution. Instead of that, we will use a formula. Whenever the lift is moving up, what are the pseudo forces? If you draw the pseudo forces, the sum becomes very lengthy. So, the best way is, imagine the lift is at rest. First, let us say that lift is not moving and solve the problem. Then we will have, just let me take this 1.5 kg, here 3 kg. Always if you want acceleration quickly, 3g will try to rotate the pulley clockwise, 1.5g will try to rotate the pulley anti-clockwise, opposing torques. Therefore, 3g minus 1.5g net force divided by sigma m is 3 plus 1.5, 4.5. Once again I am repeating, I am not using the free body equations. I am not writing 3g minus t equal to ma, t minus 1.5g equal to ma and solving that. Instead of that, net external force divided by sigma m. What is the trick here? Net external force by sigma m will give you acceleration directly. What are the external force? mg's are external force. Here 3g minus y minus 3g will try to rotate the pulley clockwise, 1.5 kg will try to rotate the pulley anti-clockwise. Therefore, we have to minus, we should not add them. So, 3g minus 1.5g by 4.5, that is 1.5g by 4.5, that will give you g by 3. So, we got the acceleration g by 3. So, once you get the acceleration, now I am going to find out the tension here. So, if you want the tension here, I can write 3g minus t equal to 3a g by 3. This is coming down, tension is upward, 3g minus t equal to ma, 3a. So, t is 2g. If you simplify that, t is 2g. Now, come back here. I can take here t and t is nothing but 2g, and here you should have 4g. That means the reading of the spring balance should be 4g. 4g means 4g Newton. If you divide by g, you will get kg. That means the reading of the swing balance should be 4 kg if the lift is not moving. If the lift is not moving, the reading of the swing balance should be 2t plus t, 2t. 2t is nothing but 4g. 4g Newton. If you want to convert to kg, divide by g. So you get 4 kg. So the reading of the swing balance will be 4 kg. Now I am cleaning this part for convenience. So you get the acceleration. After acceleration, you draw the free body equation either for 3 kg or for 1.5 kg and get the tension. Once you get the tension, T plus T is 2T. Reading of the swing balance is 4 kg when the lift is at rest. But lift is moving, keep in mind. So now I am going to take this part out. Now you know that it is 4 kg. I can put the whole to the spring balance. I can put or I can attach 4 kg and the lift is going up with g by 10. Now the sum becomes very easy. Instead of the whole system, I can put here 4 kg, because when you hold the pulley system, you can feel only 4 kg. That 4 kg you are attaching to the spring balance and let the lift move up now. So now you can write m dash equal to m into 1 plus a by g. You know this formula. All the students in the lift problems we use, when the lift is going up with acceleration, the mass appears to increase. So you have m dash equal to m into 1 plus a by g. That is m is 4 into 1 plus a is g by 10 by g, 1 by 10. This comes to 4.4 kg after solving it. 11 by 10, the 44 by 10, 4.4 kg. So this problem, if you do by conventional method, you have to do by 2-page solution, which is very difficult. So we are taking here, again I am repeating this. First we are assuming that lift is not moving. We are taking the lift to be stationary. You are calculating the acceleration and calculating the tension. T plus T will be 2g plus 2g here, 4g. So the reading of the spring balance will be 4g Newton. If I remove the g there, it will be 4 kg. That 4 kg you attach now to the spring balance. Now let the lift move up. You know, when the lift is moving up with the acceleration, m dash equal to m into 1 plus a by g. If you substitute, you get the answer directly, 4.4 kg. This is the most trickiest way of doing this problem, which is there in standard books. But I am not using the constraint equations, pseudo forces, nothing I have used. Of course, this is a standard formula which is derived already in the lift problems. You know, as the lift moves up with acceleration, m dash will be m into 1 plus a by g. If the lift is coming down with acceleration, m dash equal to m into 1 minus a by g. Those formula already known to the students in the intermediate level. So directly I have used that formula, right. Let us go for, these are all today what I am discussing is the tricky way of doing the problems. We say that question paper will be tough. Actually the question paper will not be tough, keep in mind. The examiner wants you to use some tricks to solve the problems quickly, so that you can do more number of problems and your rank will be in the top, or you can get a better rank. Because the students are unable to know the tricks, they are feeling that the paper will be lengthy, and so the paper setter cannot give a very lengthy paper. He can't expect you to do it in the stipulated time when it is very lengthy. He expects you to use some tricks to solve the problem. This is the greatest trick which is not available in any of the books. I have done it for you, so that you can do it in this way whenever the lift is moving upward or downward. First assume that lift is not moving. Second step, assume that lift is moving. Then the problem gets solved. We can do one more in that way. Yeah. Now let us take this one. what is the velocity of the sphere at the instant shown? What is the velocity of the sphere at the instant shown? I have to give the diagram here. This is the sphere. And this is moving with 20 meters per second. Okay. This is r by 5. Let us see here what are the things given here. There is a floor, frictionless, smooth surface, smooth wall, everything, all the contacts are frictionless here. All the contacts are frictionless. And the sphere moves up, velocity of the sphere, because as the wedge moves towards left, this wall is not moving, this is a wall, so it has to go upward, this has to go upward, there is no other way, because as the wedge comes this side, the sphere has to go upward, and the contact point to the ground is r by 5, where r is the radius of the sphere. Now let us, again I told you already, the velocities perpendicular to the surface, the component of velocity perpendicular to the surface should match. So let us see again. I will take this dotted line. This is the direction perpendicular to the surface. So Vs here, if I draw dotted line here, look at this here, r by 5 means this is 4r by 5, because I am minusing r by 5, this is r. So this will be 37 degrees, because cos 37 will be 4 by 5, cos 37 will be adjacent by hypotenuse, 4r by 5 by r, 4 by 5. So that should be 37 degrees, this should be of course 53 degrees, and this is 90 degrees. Now what is the velocity of the wedge in this direction? Let us see. Vs cos of, this is opposite angles, 37 means this is 37, cos 37 means 4 by 5. Vs cos 37. That is the velocity of the sphere perpendicular to the surface of contact. And what is the velocity of the wedge perpendicular to that? Wedge is moving this side with 20 meter per second. What is the velocity in this direction? In this direction. So that will be, I am writing it here, 20 cos 53. 20 cos 53. You know that in a triangle we know this is 37, 53, 94, 5, 3. Cos 53 is 3 by 5. So this is 20 in this direction. I want perpendicular to the surface. How much is that? 20 cos 53. That comes to 20 into cos 53 is 3 by 5. This will go 4 times, 12 meters per second. Now listen carefully. What we have done, let us, already I told you in the beginning, velocities component or velocity component perpendicular to the surface should match. What is the component of velocity of the sphere perpendicular to the surface of contact? Vs into 4 by 5. What is the velocity of the wedge perpendicular to the surface? Vw, this is Vw, Vw cos 53. Again I am repeating, Vs cos 37 should match with, look at my hand very carefully, Vs cos 37 should match with Vw cos 53. That is what the method is. So 4 by 5 Vs should be equal to 12. So Vs is 15 meters per second. So what is the velocity of the sphere? 15. This is a little critical problem. If you do by differentiation and all that, it's a waste of time. The best way, already one problem we have done, matching the velocity, rod and wedge. This is sphere and wedge. We have taken the velocity, well, the sphere has to go upward, the wedge is coming left side, the sphere is going upward. That is the original. So Vs is the original. Vs cos 37 should match with Vw cos 53. Look at this triangle here. You will get the angles very easily because this is r by 5 given in the question. R is the radius of the sphere. Look at my hand carefully. Vs, this is the original vector. The sphere goes in this direction, not in this direction. This is the component. Wedge goes in this direction, not in this direction. Whatever you get in this direction, that is the component. Again, Vs cos 37 should match with Vw cos 53. Why we have taken like that? Because perpendicular to the surface, the velocity of both should match. This is the surface of contact. Velocity of the sphere perpendicular to the surface, velocity of the wedge perpendicular to the surface, they should match. From that we get velocity of the sphere. Okay. So these are the tricky way of doing the problems. And in RAMABANAM College, IIT Academy, we teach lot of techniques where you cannot find in the books available in the market. You can find such techniques only here. Again, I am repeating once again. We say sometimes a student come out of the examination hall and say the paper is lengthy and tough. It is not so. The tricky ways what all I have done here, such tricks if you apply, the sums become very easy. Last one more problem we will see. Find the velocity of block B. Let me draw the diagram. Okay. Okay. Find the velocity of block B. This is B. This is 37 degrees given in the question. Now, this is a very interesting problem. Again, today if you carefully listen, there are two concepts we have used. The two concepts are what? Work done by internal force on the system is 0. In many of the problems we use that. The other one is what? Whenever two bodies are moving one over the other, the velocity components of both the bodies, perpendicular to the surface of contact, should match. That is the concept we have used. In this, what is the velocity of block B? Now you know standard triangle you have 37, 4, 5, 3. This is a standard one, this is 53. Now again I will use the concept work done by internal force is 0. What is the internal force here? Only tension. So I will take here tension T here, tension always pulls, cannot push. Tension always pulls, cannot push. Pulls the block, pulls the pulley up, pulls the block. Okay. Tension is T, here it's T, here it's T, here it's 2T. T plus T is 2T here. Very simple. One string, the same tension throughout. You have come back to a next string down. T plus T will be 2T. Now work done by the internal forces should be 0. that is sigma TV cos theta is 0. Sigma TV cos theta is 0. Actually, what is that sigma TV cos theta? T is the force, V is the velocity, force into velocity gives you power, cos theta, theta is the angle between tension and the velocity. Okay, if it is 0, cos 0 means 1, cos 180 minus 1. If it is some other angle, you will take some other angle. This is the best example to give you some other angle. That other angle is 37 here, 37 degrees. Okay, T is this side, T, velocity of this is VB. T VB cos 37 is 4 by 5. Here 2T is up, 10 downward. What is the angle? 180 degrees. Again I am repeating, 2T is up, velocity is 10 downward given in the question. So angle between 2T and the velocity is 180. So cos 180 minus will be there. So minus 2T into 10 equal to 0. Again I am repeating this. Only one line equation, the sum is solved. You need not use the constraint equations. T VB cos theta. This is the best example to give you a different angle other than 0 or 180. So T VB cos 37, 2T VA, I will take this block as A, VA cos 180 minus 1 equal to 0. T gets cancelled, or T you can take it out, T cannot be 0, 4 by 5 VB equal to 20. So VB is 25 meters per second. So we got the answer here. So we want the velocity of block B. Velocity of block B is 25 meter per second. The same problem in many books, it will be solved by differentiating, by taking the length, this is a constant length, taking a triangle x square plus y square equal to z square, differentiating, taking the constant equations, making the method little lengthy. Here there is no chance for the method to be long. There is only one equation we are doing it. We are doing the problem only one equation. With one equation you got the answer. The velocity of block B at that instant is 25 meter per second. At which instant? When the velocity of A is 10 meter per second, at that instant B has a velocity 25 meters per second. So today let us recapitulate what all we have done. The theory or the concept what I used is work done by internal force on the system is 0. TV cos theta, sigma TV cos theta is 0. With that, number of problems you can do trickily without using constraint equation, making the problem very lengthy. Okay. Next, what is the concept we used? There are only two concepts what I explained. One already I told you just now. The other is when one body is moving over the other. When one body is moving over the other, the velocity of both the bodies, the component of velocity of both the bodies, again I am repeating, the component of velocity of both the bodies perpendicular to the surface of contact, should match. I am repeating the statement again. When one body is moving over the other, rod is moving over the wedge, sphere is moving over the wedge, wedge is pushing the sphere, whatever it may be. The velocity of both the bodies, I mean the component of velocity of both the bodies perpendicular to the surface of contact should match. With that, trickily you get the answers. Okay. Good luck students. Only such tricks you can see only in RAMABANAM IIT Academy and NEET Academy. Good luck. When you come here, you will find that all the question papers will be very easy for you, because you are going to learn many tricks. Only then you will get a better rank. Good luck. God bless you.